All right, so let's talk about another aspect of visual input, which is actually object detection. So this is a relatively new approach, and this has been made possible by the recent advances in neural networks, specifically convolutional neural network, CNN. So this means it's a neural network that kind of tries to emulate the way the human eye and brain perceive objects. And if you have a sufficiently large data set up front with images and labels for the images, then you can train that neural network on a large GPU cluster, and you can actually optimize it sufficiently after the training phase that it can directly run on a mobile device. And that means that you can do things like you see here in the picture. So you can assign confidence labels to things in the camera stream, and you can do this in more or less real time, actually. And that, of course, opens up quite a number of other ways to input data into a mobile device. So you could actually like analyze the scene that you're seeing and try to for example, use that data to infer something about the context or so. We'll talk about that in more detail in the next lecture. Or you could use some arbitrary object as for position input and so on. So there's quite a number of options available now. The important thing to keep in mind is that you usually cannot actually train the neural network on your mobile device, because that just needs way too much processing power. So this is only something that you can do offline, and you'd also usually need quite a big data set for this, so hundreds or thousands of images with the correct labels. And also creating these labels is quite a labor-intensive process. So if you have a ready-made neural network that detects something in an image, then there's quite a bit of work that already has gone on behind the scenes, both for the labeling and also for the training. And once you have that, then you can use, for example, a framework like TensorFlow Lite to actually run that neural network on a mobile device or on another low-powered device, and use that to input semantic data into your mobile. So much for the kind of fundamental methods for inputting visual data and analyzing it. One kind of nice example I want to show you to round things off that combines a lot of different aspects of visual input and output is called Touch Projector. This was I think almost 10-year-old paper by now from the CHI conference. And this has a very, very nice combination of all these different factors of how you can do input and output visually with a mobile device. So the idea here is that you come up to some kind of public display. Let's say it's an advertising screen, and you can play a little game to get I don't know, discount coupons or whatever. But that screen is behind, let's say, a shop window behind glass, so you can't actually touch it. And in many cases, right now, for example, you wouldn't probably want to touch a public display anyway, even if it's a touch screen, because you don't want to catch viruses and so on. So the idea now here is that you take your mobile device and hold it up as a kind of see-through window into the world. And then when you touch the camera feed on your mobile device, then the touch is projected from your mobile device onto the large screen, and you can interact there. So that's a very nice idea. And if you look closely, then you will notice that these images, for example, here on the large screen, all have this big white border and a black background. And so this is actually an approach to make the computer vision easier. Keep in mind, this is almost 10 years old, so mobile devices weren't quite as powerful at that time. So to do the actual real-time image processing, you can't just detect the images in the video feed, or you couldn't do that at that time. You would rather just detect the white border and then use that to infer the relative position of the device with respect to the screen, and also to kind of project the touch points back onto the large screen. So even if it's quite dated by now, I still think this is a very nice combination of using, for example, the camera as input, the screen as output, the touch screen as input, the big screen as output. So it's a very, very interesting combination of various modalities, especially with respect to visual I/O. All right, so much for the purely visual part. Now let's talk a bit about other channels we have available. So some of these are kind of on top of the sensors we already talked about. But for example, we can also have biosensors. We can, for example, have heart rate sensors or fingerprint. And we can actually have quite a number of other even more exotic sensors, and of course they're not quite as widely distributed, so some of them require special hardware or just a very uncommon way of using the mobile device, so they're probably not as widely used, and that also means that users probably aren't quite as familiar with them. But still, for some types of use cases, it might make sense to have these more special types of sensors or of data processing. So one possible input channel that you kind of can layer on top of the other ones would be the shape of your hand and or body. So most of you are probably familiar with the Kinect camera that has a special type of image processing machine learning system in the back that detects the various detect joints from the image. The first Kinect is, or the Kinect series are actually depth cameras, so they have like a distance sensor in addition to the just color sensor. And for example, something like the Leap Motion that's used for various types of virtual reality input, for example, too, is also a depth camera. But with the more recent advances in neural networks, especially, again, convolutional neural networks, you can also have something like this skeleton inference hand tracking based on a purely RGB image from a mobile device. Of course, the question is how much this actually makes sense in the mobile context. So if you really want to interact with your mobile device by, for example, waving your hand above it and making free air gestures, that kind of depends. However, you could, for example, use this to implement interfaces like, for example, the imaginary interfaces we talked about earlier in a more user-friendly way, because you wouldn't need these colored markers on your fingertips anymore, for example. But still, it's a rather uncommon scenario for mobile, at least, especially if you look at the whole body stance, because then you would probably need to hold your mobile quite a distance away from yourself to capture your whole body and all the joints. Or you would need a scenario when you use the camera to capture other people and use their stance as an input. But once again, this is probably a bit of a more uncommon scenario. However, there's one subset that might make more sense for a mobile context, which is just the grasp, so the way you hold your mobile device. Is it like this, or maybe just with two fingers for whatever reason, or this camera way of holding it. And the important aspect is that you could actually use sensors directly on the device to sense this kind of grasp. For example, one of the more recent Pixel phones from Google has force sensors in the edges of the case, so it can detect if you squeeze it harder or softer, for example. And as you can see here in these images, the shape of the grasp can actually allow you to draw quite a number of conclusions from about your relationship to the object or what you want to do with the object. And this is also something that might help for mobile context sensing, for example. Another channel that is actually used from time to time now in mobile input is the facial expression of the user. this is still something which people are working on heavily in terms of computer vision and also machine learning. So you could do something like mood detection, for example. You can, of course, also do security, like actually require the user to look at the mobile device and wink their right eye or something to log in. Especially the aspect of mood detection, I think, is really still a very, very active research topic and a very difficult one too. So, because if you look at these three pictures, I think even a human might have to think twice and look twice to decide which one of these is which specific mood, for example. If is it sad or is it angry and so on. So that's actually quite different. And the way this generally works is that we have a computer vision algorithm again, often the CNN once again, to detect these kind of feature points, so the corners of the eyes and the tip of the nose and the corners of your mouth and so on. And then from looking at the relation between the distances, for example, you can kind of infer different facial expressions and then map those to moods, for example. So, and especially the second step is really quite difficult, I think. And so it would also, of course, be very error prone to try to detect if the user of the mobile device, for example, is in a bad mood and you need to now show them funny YouTube videos to lighten them up. That's probably not a very reliable use case. However, what works fairly well by now is if you just take the geometric information about these points in the face and map them to a different object, for example, to this kind of avatar. So this was popular like 2 or 3 years ago with the new iPhone X, I think, and they call it Animoji. So this is just basically a funny communication feature. It's not really something useful per se, but again, it's an input channel that you can use to map data from the environment, specifically in this case from your face, to something on your mobile device. And this is something people actually use, so some iPhone users are apparently quite keen on that. And here, kind of, this is a lot easier because you just need kind of the geometric information about the user's face. And then you can more or less directly, that's a very straightforward computer graphics problem, can map them to the corresponding points on that avatar. What you don't do here, of course, is to kind of try to map this to an actual mood. That's basically what the user on the other side is doing then when they see that animated avatar. Then they just make their own interpretation of what that facial expression means. So we're kind of sidestepping the whole mood interpretation issue here.